Hello, and welcome to this quick chat, part of Laser Focus World's Photonics Next Fall Summit. I'm Justine Murphy, Senior Editor at Laser Focus World. Today, I'm talking with Kyle Schaefer, Product Marketing Manager at Palomar Technologies. Hi, Kyle. It's great to have you here.
It's great to be here.
Well, why don't you tell me a little bit about Palomar and what your connection is to the photonics industry?
Sure, love to. So Palomar Technologies is a leading supplier of automated microelectronic assembly machines. Our machines specialize in wire bonding, die bonding, and vacuum reflow. And what we do is we actually supply manufacturing equipment for a lot of the photonics devices and assemblies that are, built by our customers. But we're not just limited to that. We also like to get a little bit closer with our customer processes, and we do that through our innovation centers that we have around the world. We have some in the US, some in Europe, some in Asia. And what we do there is we work with our customers to do some low volume manufacturing, but we also prototype a lot of their new designs, optimize some of their current processes if they have our equipment, or even if they don't, and are able to educate them on some of our manufacturing experience and just equipment knowledge. And so what that does for them is it kind of sets them up with a solid foundation for scaling up their process or introducing new product lines. And it's more of a joint benefit because at Palomar, what we get from that is we get to see, glimpses of what the new technologies are, what new process capabilities are required, and we get to add that into our own equipment. So if there's something that we're lacking or something that we could improve upon, we have a very, good idea of what that is and can start rolling that in to our machines. And of course, the customers get, obviously they get a process that's almost tailor-made for them, and they can, continue on with their production. And this kind of back and forth is really nice because what it allows us to do is it gives us kind of a bigger overall picture of what the trends are, especially, for different devices. So we have a good idea of what's going on in the photonics market.
Okay. And what are some of those trends that you're seeing?
Yeah. So some of the trends that we're seeing, I would say probably the largest trend that we're seeing is a trend towards greater power efficiency in these photonics devices. What this really boils down to is using some newer, or maybe not newer, but renewed interest in some hybrid materials in their device designs. And from what we understand, from seeing which customers are looking towards this and just from our general scope of the market, we're kind of seeing this trend emerging from some of the larger mega trends that are pushing towards this, like COVID-19 obviously pushing towards more and more digitization, some geopolitical tensions that are spurring advancement of defense and AI. And what this is essentially all leading towards is a growing need for data transmission and storage, which in and of itself is one thing, but it meets kind of a large challenge, and that's power consumption. If you look at the current relationship between the power needed to, store the data that that satisfies us now, and you look at where we think we're going to be in a few years, it quickly gets out of hand in terms of power consumption. And it really becomes unsustainable for any of these data centers to continue operating in the next, 5-10 years, just based on the amount of data that we think we're going to have to, handle. And so what we see a lot of our customers are doing is they're trying to introduce some new materials or go after some new designs that really hone in on improving their power efficiency. And that means using some of the hybrid materials that were kind of ignored for the past, a while back, but have been seeing more renewed interest in the past 5 years. And they're trying to quickly incorporate this into their technology. And so what that means is they have to roll them into, current designs or current production, and they have to do so efficiently and from a manufacturability standpoint. And that can be difficult when you're dealing with new materials and trying to roll that in. You can meet quite a few challenges, honestly, just trying to balance those things.
Okay. Can you elaborate on some of those challenges? Maybe walk us through some of the difficulties that you are trying to address for customers?
Yeah, certainly. So, one of those major challenges, like I mentioned, is introducing these new materials and new designs with, kind of like an optimized full-scale packaging setup. Because it's one thing to, say, hey, look, I have this design. I prototyped it. It works great. Power efficiency is awesome. It's another thing to say, okay, now we need to, produce thousands and thousands of these units. So you can't so easily just create a brand new design, a new process, and then expect for it to hit the market running. And so one of the ways that our customers try to get around that is they look towards, legacy or current manufacturing processes and packaging techniques, and they try to fit their design into those processes and techniques, rather than just going with a brand new process that's not supported in the industry. And this technique is obviously going to be very effective, right? Because if you develop something for the current technology that's out there, the current packaging techniques, the current packaging equipment, subsequent materials, then at the end of it, you can fairly confidently roll it into production. But you're also trying to take something that's new, that has very difficult requirements of power efficiency, and fit that into these molds that were designed for these other processes. And that's difficult. It's a lot of trial and error. It's a lot of does it work like this? No, nope, that's not quite getting it, or that's not quite robust enough. And thankfully you have a lot to choose from. There's a lot of different things out there, but that also kind of complicates it. I mean, for example, let's take interconnection methods, right? So that's you have a few components in a device and you need to get them electrically connected to one another. There are so many different ways to do that. Like even just looking, and then each of those ways has a lot of requirements and different process equipment that's needed to do that. So for instance, if you look at let's say flip chip attach, right? Very straightforward. Let's say it's using either gold bumps or copper pillars. Well, even just on the die attach side, you need a machine that has high precision, that can support localized heating, that has both top and bottom vision-based pattern recognition. You potentially need force in the kilogram plus range. You need tight planarity control. You need a mechanism for flipping the die if they're not presented that way. And that's not even counting all the different other factors that you need. Does it need to be automated? Do you need a conveyor? Do you need some other assurances to make sure that you have high quality of your production? And then you also need a ball bonder to bump the die if you're using the gold bumps. And that's just for one single portion of interconnect method. So if you say, have this material, we're going to try to fit it into a flip chip process using a flip chip machine, you need all those things on that machine. But then you find out, oh, well, maybe that's not going to work. Let's try another one. Okay, well, what if we do epoxy die attach with, wedge bonding with gold ribbon? Okay, that's one way. Or eutectic die attach with ball bonding with gold wire. Or, eutectic with wedge bonding with aluminum wire, so on and so forth. You can see how it spools out into this vast array of choices. And the unfortunate part is that could mean, a bunch of different equipment, and you can't just go out and buy all that equipment. And so that is really one of the challenges where, both in terms of time and in terms of investment, it can be very difficult. And that's why, having the ability to be flexible in some fashion when you're looking at these, process development steps to kind of, challenge these or tackle these challenges in the market is really, really important in, the photonics industry.
Right. Well, so flexibility certainly seems like a welcome capability. So can you talk a bit more about what it means to be flexible in the photonics packaging sector in particular?
Definitely. So when I mention flexibility, I'm essentially categorizing, at least from our perspective, as having the most amount of process techniques with the least amount of investment, right? Because you can certainly go out and purchase 10 different machines that have 10 different functions, and each of those are perfect at what they do and can solve, whatever path you want to take your package or your device down. But that doesn't make a ton of sense, right? That's not really feasible, especially when you're saying, okay, we need to make a quick turn on this and we're trying to, have a product that we want to sell. You're not going to go out and dump a bunch of investment in that short of a time frame. And if you look towards the future, once you do settle on something, what are those other 9 machines or 8 machines or 5 machines going to do, right? They're going to lose their purpose and then they lose their value. So ideally, you can have 1 or 2 machines that can cover the majority of your heterogeneous integration processes that a device may require. And you can have a solution that's not only good for ROI, right? But also just for speed of development. So you don't have to go out and wait to procure a new device or procure a new way to do this, or go to another contract manufacturer because they have a capability that the one you were using prior didn't have. So that's what I mean when I say a machine has to be flexible, right? They have to not just have the option to run other processes, but they can do them all pretty much at the same time, right? So all the equipment is there. So if today I wanted to do something and I want to do, a completely different process in the afternoon, the equipment's there. I can, easily and readily try that out. You're not having to worry about, major changeover time, which is just like physically changing the options on a machine. You don't want to have to take the machine down out of production or out of process development to have to set it up so that way you can do something else. And that is extremely important, right? That's going to make your process development quick, easy, and it's going to make your ability to adapt to unforeseen circumstances a lot quicker. Let's look at just like another example for that. So again, we'll look towards a die bonder because that, definitely one of the most varied in terms of process capabilities. So let's say, what is the example of a flexible die bonder? Well, it should have first and foremost like the space to accommodate all the different mechanisms and tools for the die attach capabilities that are out there. It should be able to handle epoxy dispensing, maybe silver sintered paste jetting. It should be able to handle eutectic soldering, localized heating for precision reflow, UV curing for both in situ and a flood UV cure if you need it, die flipping, wafer handling, both for die ejection and for placing onto a wafer, plasma cleaning for stronger bonding using UV curable adhesives. That's something that's really important to have, and having that locally on the machine and is not only going to make it a lot better because you can plasma clean and then bond, but it's also going to make it a lot more convenient. It can even be used for things like surface bonding, and then it also needs to have all the tools to handle your components, right? So that's material presentation and manipulation of these components. So that can come in the form of a tray feeder, tape and reel feeder, gel or waffle pack presentation, wafer die ejection, as I mentioned earlier, conveyor, a heated conveyor, and then you need all the different, pick tools to manipulate those. So some machines have those as the form as vacuum pick tools. Some of them have grippers, but you're going to need specific ones for specific devices. So if you can have all of that in a single machine or one or two machines, you're going to be set, right? Because then you take your package, you try to build it up, you go, that didn't quite work out. You can very easily switch to something else in, a matter of minutes or a matter of hours, rather than having to procure something, wait weeks for it to arrive and halt your process development. So being able to handle all of those current or legacy heterogeneous integration techniques is really the definition of, a flexible machine, especially when talking about the photonics industry.
Right. Well, are there any specific tools or characteristics that make this possible, or is it simply just having that big machine so you can fit everything inside of it?
Unfortunately, it's not just like having a big machine to put everything inside of it, just because, you need them all to work together in tandem. Obviously, having the space for everything is an important factor, right? I mean, you can't have a tiny machine and then expect to put everything in there. But in contrast, you can't have a giant machine that costs a lot of money, that takes a lot of room up in your lab space or your production floor, and say, oh, that solves the machine. It's not 10 machines; it's just 10 machines glued together. You need this to work in a smart way. And again, it comes back to balancing the equipment capabilities and your investment. So one of the tools to kind of get around this is having a more scalable system. So that's, I would say, more of like a characteristic of, that's required for a machine to be flexible. So when you order the machine, you can get it in a, less, at a lower investment point, right? You don't have to have every single process capability on there. Maybe you have the ones that you need and ones you may need in the future. But it should be very easy and very simple to add on to that rather than having to get a whole new machine. The difference in investment between buying a whole new machine just for one process capability versus adding something on into the field that's easily retrofittable and quick to do is just, obvious. So if you can have at any time the ability to add a new process capability, that's going to be a huge plus for rapid process development. As far as other tools for flexibility goes, is you can have, maybe something that in the software that makes it easy to transform one process to another, right? So that would be ease of programmability of your procedures for your building, or ease of, changing one type of process to another. So let's take like two processes, both eutectic, but vastly different approaches, right? Let's say you're building a device on a heated conveyor with a die that has a pre-metallized backing, right? So that's going to be, you pick up the die, you move it over to your substrate in the heated conveyor, you press down, you let the solder reflow, you're done, right? And then let's say you are now building these assemblies instead on a wafer stage with a localized heating tool that uses eutectic preforms, right? Still trying to get a similar approach, but the mechanisms and the steps are a lot different. First, you have to bring the preform over, then you have to pick up the die, heat up the die in the tool, place them down there, and reflow the solder. At the end of the day, you're still eutectically attaching, but in terms of telling a machine to do that, it's going to be vastly different steps. So if you can have something that is quick to change over from one to the other, that can easily say, hey, I'm now going here instead of there, I'm using this instead of that, and it's not a chore to do, then that's going to make it a lot easier for you to focus on the results, dissect those results, and continue your process development. So it's not just about having everything, it's ease of use. It's software tools that can expedite that process. That's going to, save a lot of time compared to trying to transfer, a process that you developed on this machine that's designed for a conveyor and heated attach versus, and then now take that and bring it over to a completely different machine that's designed for wafer bonding with localized heating, right? If you try to do that, that's going to take way more time than just having a single machine with a unified process environment that you can quickly move stuff over. So, and that's, just a couple of things, but there's quite a lot of tools out there that can certainly help, expedite the process development. And overall, flexibility is really what photonics packaging engineers and designers need to look for. If they don't pay attention to that and they just look at, core numbers or the cheapest product, then you're going to, risk severely hampering your development, right? You could invest too much in a piece of capital equipment that only serves a single function that falls short a year later or a few months later or just a couple of years later. You want something that's going to grow with your company and be able to support your production once you are able to finally figure out how to make that product. So, and that's just stuff that we see a lot from our interactions with customers, and that's what we were really hoping to convey.
Okay. Well, thank you so much, Kyle, for being here. That was great information to be able to share. On behalf of Laser Focus World, I'd like to again thank Kyle Schaefer from Palomar Technologies for joining us for the PhotonicsNXT Fall Summit.
Thank you.